Hi, in this video, we want to take a brief introduction into data visualization. All right, so data visualization is where we take our data, our observations, our measurements, and then we apply some mathematical formulas to create a picture to represent our data. This gives us a faster way to interpret much of the data that we have. Now, will it be a complete representation of our data? No. If I have millions of rows of data points, I probably won't be able to represent all features of my data, but I can get a good overall impression of what's going on. All right, so why do we use data visualization? Well, we have several reasons. So first one is to communicate complex information. Second is to identify outliers and anomalies, to make data-driven decisions, to monitor performance, and to explore the data. And personally at work, I use data visualizations for all of these reasons. So when we communicate complex information, data visualizations make it easier to understand complex data and communicate it to others. By presenting data in a visual format, we can quickly identify patterns, trends, and relationships that might be impossible to detect in tables or written reports. We also use data visualizations to identify outliers and anomalies. Data visualizations make it easier to identify outliers and anomalies in data sets. These are data points that fall outside the normal range of values and may require further investigation or further actions to make data-driven decisions. So data visualizations help us make data-driven decisions by presenting the data in a format that is easy to interpret. By looking at charts and graphs, we can quickly identify which areas require attention and make informed decisions based on the data. To monitor performance, and this is one that I'm currently using at work, data visualizations allow us to monitor performance over time and track progress towards specific goals by creating charts and graphs. We can quickly identify trends and make adjustments as needed to stay on track and to explore the data. And this is the one where I use the most, at least in terms of the volume of visualizations. Data visualizations allow us to explore data and generate new insights by creating different types of charts and graphs. We can imagine, or we can examine data from different angles and identify new patterns and relationships that are not obvious in other formats. So data visualizations help us better understand, communicate, and analyze data. They are essential tools for decision making and performance monitoring in fields such as business science and public policy. So the reason why these are so important is that we think with our eyes. And since we think with our eyes, we can come to conclusions faster if it's a visual representation. All right, so let's talk about some common types of data visualizations. All right, there are tons and tons and tons out there. I just grabbed a bunch and threw them into this video. There are others like box plots and histograms that we will get into later in the series, but for right now, I'm just going to touch on these. So first type is a line chart, which is used to display trends over time. Line charts connect data points with a straight line. Bar charts are used for comparing data across categories. They display data using rectangular bars that are proportional to the values they represent. So the height is proportional to the value they represent. Scatter plots. So here we have two numeric variables that we want to understand better. So scatter plots visualize the relationship between two numeric variables. Each data point is represented by a dot on the graph, and the position of the dot indicates the value of each variable. So this is the standard XY Cartesian coordinates. Pie charts. Pie charts are used to represent parts of a whole. The chart is divided into segments, and the size of each segment corresponds to the percentage of the whole it represents. Then we have heat maps. Heat maps use color to represent values across a grid of values. They are useful for visualizing large data sets with many variables. Tree maps. Tree maps are nested rectangles to represent hierarchical data. And the size and color of each rectangle represent a different variable. Then there's bubble charts. Bubble charts are similar to scatter plots, but each point, the size corresponds to another variable that we want to represent visually. And the last one that I'm going to talk about are network diagrams. Network diagrams are used to represent relationships between nodes. They are useful for visualizing complex systems such as social networks or computer networks. All right, so let's go ahead and go through some data visualization examples using R. So first one we're going to do is a line chart. And I'm going to be using ggplot for almost all of the examples that we run through. So the trend is going to be we're going to build a data set, and then we're going to drop the data set into ggplot to create the plot. So the plot is going to be as minimal as possible. And the reason why I'm doing as little as possible in the example is so that you can see what's important for creating the visualization. When I get to like the best practices, these examples are actually going to contradict those best practices because I'm doing the most simple, basic stuff I can for you to be able to understand the example. And so here in ggplot, we always drop our data, and then we use an aesthetics function to say which variable takes which role in my plot. And so here we're saying X is the year, Y is the sales. And then in ggplot, it's a geom function that tells R what mathematical structure do I want to present visually. And so here we want a geometric object of a line. And so here we got it. And here we can see the X, Y of year and scale, and then we get our beautiful, nice line. Now let's talk about bar charts. All right, so for bar charts, what we're going to do is that we have some categories and we have some numeric value connected to those categories. This could be a count. This could be an average. There, plenty of different ways that we could go about this. And so how we're going to do this is that, get rid of that. I put my data into ggplot. I set up the aesthetics mapping between my data column and the role it plays in the visualization. So we're saying that the X coordinate is the category. That's the horizontal axis. The Y coordinate is the value, which we have set here. So we have on the X axis categories, nominal data, and we have numeric data on the Y axis. And then we're going to use geom bar to set up the actual rectangles. And so here we can see what we've got. The height of the bar corresponds to the value that we put in. Now for the scatter plot, we're playing the same game, but here we have two different numeric values. Notice that previously I had a categorical on the X and numeric on the Y. Now I have two numeric variables to work with. I'm putting my data into ggplot. I'm saying X is my X coordinate, Y is my Y coordinate, nice and easy. This is the aesthetics function. And then I say geom point to put points on the Cartesian XY plane. And that is our scatter plot. Can you see why we call it a scatter plot? Next one is a pie chart. And in general, professional mathematicians and statisticians avoid pie charts. In reality, people tend to misunderstand and misinterpret pie charts. But honestly, people like them. People seem to embrace them and trust them, I feel like, more than they should. So what we're going to do, we'll use them if that's the way to communicate with our audience. Honestly, bar charts, in my opinion, are better for most uses, but I've encountered clientele with weaker math backgrounds that don't like bar plots, but would be receptive to a pie chart. And so here I have very similar data to what I had before. I have my categories, and I have some values. And what I want to do, I want to represent what proportion of A is the whole, what proportion of B is the whole, what proportion of C is the whole, what proportion of D is the whole. All right. And so to do this, I'm going to make it a pie chart. And here I drop my data in. Here I have my aesthetics. Once again, now you'll notice I don't actually specify what the X variable is. I'm just leaving that blank. That's just a ggplot, aspect to it. Here I've got the value and then here I'm saying fill is the category. So the category corresponds to the color. So there's two ways to establish color in ggplot, two standard ways. First one is color and the second one is fill. Here we're using fill. Now we're running geom bar. And I'm using stat equals identity. So stat equals identity says use the value that I specify in the aesthetic function. And then here we're putting things into polar coordinates so that everything goes circular instead of a bar plot straight up. I guess I should look at this. And here we can see that the size of the pie corresponds to the proportion that each category represents in our data set. Now for a heat map, what we need to have for this particular function, this geom tiles, we need to have a grid of values in terms of X and Y, and then we have to have a third variable that will correspond to color. So what we're going to do is, once again, just like with a scatter plot, I have an X and Y coordinate for each position, and I have a number tacked onto that, in addition to like what we have for a scatter plot. Now, for this particular operation, we need to have the X's and the Y's cover an entire grid of values. And when I have that, this is a good time to use a heat map. And so, how do we do this? We are going to have an X coordinate, a Y coordinate, and then another variable that establishes what the color intensity is going to be. We run geom tile, and here the scale field gradient is just specifying what are the high and low values of the colors. And so we can see that low is white and high is red. And so we can see geom tiles gives us this grid of values, and we can easily pick off where are the more extreme values in the data sets over the grid. Now, a tree map is a type of map for like nested data. All right, so what I'm going to have a group, I'm going to have a subgroup, and then I'm going to have a numeric value. All right, so a way to think about this. Think of this as if I have a chain of grocery stores that is group one, subgroup is each area of the store. So like maybe the meat section, the milk section, the frozen section, the dairy section. Each subsection is my subgroup. So in my data, I have, pretend I have a bunch of money that represents the amount of money I've made in each section of my chain of grocery stores. Each inside the group, I specify what is the grocery store that the data is talking about. In the subgroup, I'm specifying what section of the grocery store there is. So every grocery store has a dairy section. Every grocery store has a produce section. Every grocery store has a frozen section. And what I want to do, I want to be able to analyze what's going on, with overall with what's going on. And a tree map is a good way to do this. What this is going to do is that this is going to group. I'm going to have like rectangles with sub-rectangles. And so the big rectangles will correspond to groups. The smaller rectangles within the groups will be the subgroups. And then the intensity of the color will correspond to the value that I want to represent. And so here I'm generating some fake data. So the letters correspond to the groups. Those will be the big triangles. The subgroups correspond to the smaller rectangles. And then the value is going to be the intensity of the color, so I can visually interpret what's going on. And now I'm going to run the tree map, doing exactly what I said a moment ago. And so here we can see that A has like green rectangles, B has, let's say, pink rectangles, and C has, I'll just say, blue rectangles. And we can see that like 1 is the least intense color, and so we know that this is the least of the values on average for each of these. We can see that 2 and 4 have greater within B, and we can see that 2 and 4 also have greater in A. So, And so this enables us to just kind of like figure out what's going on, just judging visually. Now, a bubble chart is a scatter plot where I increase or decrease the size of the point by another variable that is interesting to us. And so actually, I just sent one of these to a stakeholder last Friday for the purpose of monitoring a process. And so here, we're going to have 3 variables. We'll have our x coordinate, our y coordinate, and then the size variable. And so here in my data frame, I'm just saying x is the x coordinate, y is the y coordinate, and the size is another variable for that scatter plot. And then I go through and I do exactly what I did before. I drop my data into ggplot. I specify the aesthetic mapping from variable to plot. Pretty easy to track it when it's x equals x, y equals y, and size equals size. And then I'm running geom_point, and it picks up the size aspect automatically and figures out the size for me. Now the alpha, what this will do is that this will make my points somewhat transparent. And so that way, if I have overlapping points, it's easier for me to see the overlap because of the transparency. And so here we can see how the size varies, and I can use this to figure out trends in my data. This particular plot, I don't see any trends, don't see anything going on. One thing that is nice, we can see the overlaps very easily because of that alpha parameter. Now this next one is a network diagram. This is for something where I have like relationship of being connected. And when we do this type of graph, we also need to consider if things are directed graphs or not. If you take my data prep course, we will go knee deep and upside down in Bayesian acyclic graphs for modeling, but we're not doing that in this course. I've got that elsewhere on YouTube. So here we're going to just take a data frame and generate a graph from and when I say graph, I mean like graph theory type of graph. And then here we're just going to plot it. So G is my graph. I put it into the plot function and I label the vertices. And so this enables me to see what are the connections between different nodes. All right, so now let's talk about best practices. So first and foremost, I need to choose the right type of visualization for my data. So I need to choose a visualization type that effectively communicates the data I want to display. Different types of data require different types of visualizations. Next one, keep it simple. Avoid cluttering your visualization with unnecessary details. Focus on the most important information and avoid distracting or confusing elements. So here, one thing that I have learned the hard way is that less is more. It's better to have a simple graph that communicates well than a slick graph that's hard to interpret. Always try to give simple graphs. If you need to do a complicated graph, do a simpler version first, and then make it a little bit more complicated than a little bit more complicated until you reach the full information you're trying to show. We want to use clear and concise labels. All right, so I did not do this at all in this video, because I was just trying to give you like simple examples so you understand the code. But this is absolutely critical for successful communication. This is a huge thing that you must do if you want to be successful in industry. The labels should clearly identify the data being displayed and any relevant units of measurements. Use a legible font and avoid cluttering the visualization with too many labels. Consider color carefully. I always use color, but I only limit it to like at most 7. I prefer to keep it down to 3. 5 is okay. So I'll use color to highlight the important information, but I'll avoid using too many colors or using color that are too similar. Color blindness is common among men, so consider using color blind friendly palettes. We're going to provide context. So I'll provide context for the data being displayed, including relevant background information, comparison of points, or historical trends to help viewers understand the data in a broader context. Use appropriate scales. Usually this is pretty easy done for us by the machine. Be honest and transparent. So how I usually do this is I actually indicate in my plots where I got my data, and that will help people buy into what you're telling them. And just take a look and judge your visualization and double check it before you show your audience. All right, well, my battery's dying, so I'm going to end the video. So that's all I've got for you. Life is short. Do math.